Hi everyone, my name is Huang Bo Yang. Today I will introduce our work, stock closing price prediction using machine learning. And here is our group member, Chen Juncheng, Lü Yemi, me, and Deng Yujie. And here is our outline. Introduction to stock forecast. Introduction to homework model. Prediction results, conclusion, and the final references. Stock trading is now the mainstream investment mode with the operation of the market industry chain. Stock market analysis has always been regarded as a very hot topic. What we can know is that each type of industry will belong to its peak season and low season. We can follow the logic of the past and use deep learning to predict the future of the stock market. If we can make judgment based on the past close prices and the industrial chain cycles, we have the opportunity to make models judge future stock prices. We hope that through deep learning, the data prediction can be simple mode with an error view within about 5% to show the future direction of the stock market. Here we take TSMC as a sample. Look at the closing price from July to December of each year. In the TSMC sheet, we can see there is only one season is green, so for the peak season, this will be a good data to training and predict. We just take July to December as a sample. Here we can see since it's the beginning and the end of the peak season, it can be seen that in early December, most of closing price are rising. In the homework, the teacher used Gate, RNN-GRU to edit the program. Here I'm going to compare the example from teacher and our work. First sample from teacher are using 16 floors GRU and dense, and our is using 256 floors LSTM and dense. The result of using GRU to judge is quite close. But when we use GRU to predict the closing price for 2 weeks, the error will become larger. If we want to make long-term investment and evaluate the stock market from the perspective of monthly and quarterly lines, what modes can achieve the results we want? We change the step, use the LSTM mode and adjustment the training parameters to complete the challenger. We will replace the GRU mode with LSTM for testing. We can see that according to the forecast result, after 5 days, GRU is closer to the actual data. But when we switch to the 20 days results, LSTM is closer to the answer than GRU. Let's see the AVG box. When the data result is short, the GRU will be better, but when the database is large, LSTM will be better. We can look at the next results on 20 days and 60 days. It can be found that the effect of the LSTM is more better than the GRU mode. Long short-term memory is a spatial RNN that can learn long-term sequences. LSTM uses a total of those three gates as input gates, forget gates, and output gates. Input gates decide which message need to be stored in long-term memory. The forget gate decide which information in long-term memory is retained or described. Output gate use privacy data to calculate new short-term memory. And here I'm going to introduce the gate. In LSTM, they have input gate. The input gate decides which information will be stored by long-term memory. It only works with the information from the correct input and short-term memory from the previous step. At this gate, it filters out the information from variables that are not useful. And the second, forget gate. The forget decide which information for long-term memory be kept or described, and this is done by multiplying the incoming long-term memory by a forget vector generated by the current input and the incoming short memory. Output gate. The output gate will take the correct input, the previous short-term memory, and the newly completed long-term memory to produce new short-term memory, which will be passed on the cell in the next time step. The output of the correct time steps can also be drawn by this hidden state, and why we need those gates. RNN is limited by short-term memory. If a sequence is long enough, it's difficult for them to transfer information from an early time step to a later time step. So RNN may miss important information at the beginning. Here I'm going to compare the GRU and the LSTM. The GRU has two gates, update gates and recover gates. LSTM has three gates, input, forget, and output gates. GRU doesn't perceive any internal memory. They don't have an output gate that is present in LSTM. As the GRU is more faster because they have no output gate, so the GRU is a faster improved version of LSTM. When we run the experimental results, we clearly felt that GRU is more faster than LSTM, about 1.25 times. And LSTM is suitable for long-term memory data operations. GRU is a faster improved version of LSTM. The conclusion. GRU can use for training parameters, so it uses less memory and is faster than LSTM. But LSTM is good at large data set. So if we deal with the large data set and still need, actually the LSTM is the best choice. And here is our reference. Thank you for listening.